give you some examples of the technology of our age. I'm going to highlight a couple of them, those that you're probably most interested in. And so one thing we know about the Internet of Things is because of smart cities and everything else, it's taken off. It's hit the knee in the curve. And now we're talking about billions of devices. The thing that's interesting is billions of devices that can create millions of data points. How are we going to figure out what it all means or how it all works? Uh, so why do we want smart cities? Well, naturally, if we can replace people with machines, it's a lot cheaper. We have more data than we ever had, which means better reliability because we can predict better, and so on and so forth. And so, what drives the Internet of Things? Well, low-cost semiconductors. I mean, why didn't we have the Internet of Things all along? I mean, we've had sensors for decades, we've had computing for decades, but semiconductors have become small enough and powerful enough that we can handle all this data. Silicon sensors can be as low as $1 a piece. So all of a sudden, now you can cluster all these sensors together. Before there was an IoT, Dr. Chow was actually working on it. Back then we just called it smart machine systems. One thing we had to take into consideration is how are all these data points going to communicate together? There was no internet back in the late 80s. And so uh, how, how are you going to communicate between all of this? And we have the internet now, which allows us to do that. And plus we have cloud computing, which allows us to link everything together. And so in terms of IoT, what do we use it for? And we use it for control and alerts, systems I talked about. We can use it for stakeholder collaboration, that everybody has access to this data. And so different parts of your value chain can communicate together. And not only that, with better data, we can make a better customer experience. And so the impact of it is, if you're a company and you're a software company, do you really want to get involved with all this hardware and infrastructure? And so integrating and how it goes into your supply chain can get pretty complex. And this is why they have what's called now domain specialties, that you want domain experts, people to handle this kind of stuff for you. In terms of security, anytime you talk about data, security is an issue. And we'll talk about blockchain with regards to that. And so in Europe, they got into actually the wind turbines. So that's kind of scary. Big data, it's how am I going to manage this data? Now, the 5 V's are the data elements that we're concerned about, such as velocity, how quick can we get it, how much we're going to look at, which is volume, veracity, how truthful is the data, can we really trust it? And one of the biggest V's of all is actually variety, meaning images, numbers, words, all have different kinds of meaning when it comes to data. And finally, what kind of processes? Again, now that you have all this data, what are you going to do with it? And so you become a data-driven organization. How does that change you? Blockchain. A lot of you have probably heard about it. A lot of you probably already know what it is. And what's in a block? What is a block? Well, a block is basically a record. It's a chunk of data. Like, for example, how much I want to purchase, or how much information am I moving from one point to another. And what happens is that each time I enter this new chunk of data, which is a block, and the thing is, a block has limited size. So if I have a lot of data, this could entail a lot of blocks, but they're linked together by cryptography, meaning there's some kind of security element, like a 16 number sequence or something like that, that links each block together, and that's referred to as a cryptographic hash. Within each block is information about the previous block. So the record is kept and they're linked together. There's also a timestamp, and there's also the transaction data, which is called the root hash. And so when we look at a block, the hash, we have different types of data. that's in there. Concatenation is how are all these little blocks linked together. Cryptographic hash, which exists within every block, is again that connection between block to block of the previous one. And so what happens is every time, so essentially all this recording of information, what is it really? And what it is, it's a ledger, meaning here's a transaction, here's the information, here's the date and time stamp. Now, what makes blockchain so unique is when you have all these blocks, who controls it? And it's everyone in the block. There's no central figure, which is typically what happens with data. And so therefore, if I have 1,000,000 blocks, then guess what? There's 1,000,000 people who authenticate it. Not only that, but before a block can be introduced into the other blocks, the other users have to go ahead and approve it. So it's decentralized, and also it's peer-to-peer. That when you think about data transactions today, what happens? I go to the bank, I have to go through the bank system in order to talk to something. In a block, everybody involved in the block is connected together. And so this is where you create a peer-to-peer network. Boy, that went by quickly. Yep. I just want to make sure I didn't skip an icon. Anyway, so I have my block, and what's also in there is it tells me about the parties, who's participating, but we use digital signatures, meaning you use an ID. Some people choose to use their names, some people give them names, give themselves names like Hot Rod or something like that. And not only that, but every hash in the block is unique. And so the process is you have to have a transaction take place first before a block can be added to everything else. And so if you go halfway through the transaction or something like that, it doesn't get added. It's got to be verified. The other computers in the chain say, okay, it's okay to put this in. And so your blocks are only 1 megabit. And so if you have a lot of information, you could have conceivably thousands of blocks. And then once it's verified, then it gets a hash identification. The thing about the hash is the way you can think about it is it's a complex math problem that has to be solved. And that's the cryptography aspect of it. So we record it, we store it, but you can't edit it unless everybody else in the chain agrees. You can actually see what's on blockchain. You can go to blockchain.com and see all the blocks that people have put in. So the thing is, how do you manage 1,000 of these things, or with so many people in the chain? How do you figure it out? Well, what happens is if you want to join it, typically what most chains go through is a consensus model, meaning you need 51% of the people to agree. But how do I know I can't hack it? Well, if there's a record of the previous chain and all, I can hack into a block, and I can change the hash and change the information. But guess what? I've got to do it for every single location, even if I could get the approval. So for a hacker, it's just too darn hard to get into. And so so as an example of blockchain, the biggest thing of all right now is in finance. And finance, it makes sense to have blockchain because you have all this great security. What they've actually done is created what's called a fiat currency, meaning currencies are arbitrary. I mean, there's so many of them. What does a currency actually mean? Actually, one big misconception people have is when I, for example, buy something in Europe, what I'm actually doing is trading my dollars for euros. I'm not actually converting it over, meaning once I do that trade, somebody is holding my dollars. And this is why the euro was created, because all these separate countries, and it's all because of Ronald Reagan, he ran up so much debt. You had all these separate European nations holding enough dollars, and they didn't have enough influence over the currencies. They said, hey, why don't we pool all our money together and we can stick it to the USA. But that's the story of how the euro got started. But anyway, I can come up with an arbitrary one saying, I'm going to call my currency Dr. Cho. And so if you have one Dr. Cho, that's worth a gallon of milk. And so it's arbitrary. So that's what a fiat currency is. And so in order to get into a block, the way you can think about it is you have a 1 in 7 trillion chance of breaking in. That's how hard the encryption is. And so when I add a block to a chain, this is what's referred to as mining. And so hackers aren't going to want to fool with it. And so how does this all work? Well, what a wallet refers to is that you need a program in Bitcoin in order to be able to run transactions, and that's referred to as your wallet. Your private key is what you need to do to run transactions, and your public key is basically what everybody else in the chain and the public can actually see. Here's the problem you have. If you lose your key, you no longer can use your wallet, which means you can no longer get into the chain. And so yeah, that's kind of important information to have. And as I pointed out before, they have consensus protocols and typically, majority rules. So what they have with these currencies is initial coin offerings, which is kind of like initial public offerings. Instead of offering stock, they offer cryptocurrencies. There's over 2,000 of them running around. 39 of them have a valuation of over $1 billion. And of course, the granddaddy of them all is Bitcoin. And then you compare that there's 180 legal tenders around the world. There's a little video attached, and you can see the disaster of what happens when you lose your wallet in Bitcoin. And so after you watch the video, this lecture will continue.